How is everybody? Everybody doing all right? No, everybody's terrible. It is 5:20, so, well, it's not quite 5:20. It's almost 5:20. So it's been a full day. Has anybody seen anything good? Yes. What have you seen that's good? The serverless GraphQL, the one that was just before this. So I have to follow that, is what you're saying. Okay. No, GraphQL is cool. She did a good job. That was a good talk. What else? What else has been good? Immutable JS. So just out of curiosity, who in the room are JavaScript developers? I'm going to make an assumption that if you're in a JavaScript talk, you're at least familiar with the concept of JavaScript. Are most of you .NET developers? Okay, the majority of you, vast majority. Do I have any like Java, PHP, Ruby, Python? No, okay. Excellent. So anybody just JavaScript? You don't do any .NET at all? So just two. The rest, okay, excellent. So you're all what you would say full stack developers. You do GraphQL stuff on the back end, and then you do .NET Core in the middle, and then you're doing React or Vue or something on the front end. Yeah, it's all new. Learn everything new once a year if you're lucky. That light is very bright. I gotta stand somewhere where it's not like. Okay, I have never done this. I promise, but I'm gonna do it just for the fun of it because you guys are awesome. Everybody look like really irritated and angry to be here. You probably assumed I was gonna say something different than that. Okay, are you ready? All right. I probably won't even do anything with that. It was just fun. I've never done it before. I thought I'd do it one time. All right. So I'm going to start 20 seconds early. I hope you guys don't mind. So this talk is Solid.js. How many of you in the room are familiar with the solid design patterns? Okay. This will be an easy talk. Okay. If you're already familiar with them, why are you here? Yes, okay, excellent. Because when you see these two things together, that's weird, right? Because if there's one word we can use to describe JavaScript, solid is not that. This is my definition of JavaScript development. Kind of in general. How many of you live this every day? Who does React? React is getting there. It's not horrible. Angular has TypeScript sitting on top of it, which in some cases helps, and in some cases makes everything so much harder. Do you have any Vue developers in the room? Vue, excellent. I anticipate at this time next year there will be more than one hand in the room. Vue is rapidly becoming the next big thing. So if you just learned React, sorry, you're going to have to change here pretty soon. So the point of this talk, and this talk is going to be, it'll be practical, but if for everybody in the room who raised their hand when I said solid, I'm gonna stretch you a little bit. So when we build our back end code, right? C#, solid principles. We build things that are nice, right? You were very excited about that. Yes. So because we take a lot of time. We have architectural meetings about how we're going to do our APIs, and we just think really hard about how we make this stuff great. And then we build our front end. And there's a lot of duct tape involved, and we get it to where it works, mostly, but you don't want to change it, because then you have no idea why it works to begin with, right? So we're all there. I am only a JavaScript developer. I don't do anything else anymore. I was a .NET developer for a long time, but and it's still, I mean, right? There's lots of duct tape involved in JavaScript development. So what the purpose of this talk is I'm going to give you some things to think about when you're building your JavaScript applications. Just like stop for a second, take a deep breath, and think about whether what you're doing is the right thing or how you can improve on the thing you're doing, which is something you already do on the C# side. Like that's normal, but let's bring it forward. Okay, so this part, I assume, based upon the people who said they already know this, will be pretty easy. So with be review, but we'll walk through it. Okay, so what is solid? I'm not gonna call on anybody. Yeah, I will in a minute. So 5 design principles intended to make software designs understandable, flexible, maintainable. All those words that you do not associate with JavaScript development in any way. But it's okay. Right, basically it's just a way to make you stop and think for a minute. Are you writing code that you understand? Are you writing code that you can modify if needed? Are you writing code that's maintainable? Real quick, there's 5, right? Single responsibility principle, that's the S. Somebody who is brave. I will not correct you, I promise. What is the single responsibility principle? Yes, you do one thing. So you're supposed to do one thing, and that's what you do. Absolutely. See, it's easy. It's not a trick. There's no trick questions. Open close principle? Yes. Okay, see, only one person answered the first, and now everybody's comfortable. We're warming up. So good job getting the ice broken. Right, open for extension, close for modification. Anybody? Liskov substitution principle. Okay, we'll come back. We'll come back to this one. Never mind. Okay, no, we'll come back to this one. Interface segregation principle. No, but that's the point, right? Okay, so interface segregation principle is, build simple interfaces. Things should be easy to use. And the dependency inversion principle, you want to inject dependencies. We'll talk very detailed about these last couple. Now, as you have pointed out so wonderfully, because it's true. Oh wait, I'm not there yet. Okay, so solid principles are a means of forcing us to stop and think about the right way to do something. I said that already. Okay, so to what you were just saying. JavaScript does not, okay, wait, let me be careful how I say this. JavaScript has types, yes. JavaScript is weakly typed, which means you can change types whenever you want to for no reason whatsoever. JavaScript does not have interfaces. JavaScript does not have a lot of things that when you look at how the solid principles are implemented in a .NET type environment, it doesn't work. Right? So what we're going to do here is I'm going to take the principle and we're going to walk all the way back to why the principle was first discussed. And then we're going to find a way to take that thought and apply it in JavaScript. So when I get to interface segregation principle, I know that it's not the same thing. Just work with me. Okay. So, okay, so first one's first. Single responsibility principle. So while I'm doing these, I did not create these. Has anybody seen these before? Okay, a couple of people. I stole them shamelessly from Los Techies. They had a blog for a long time. Okay, right. How many of you have ever worked in code that looks like this? Right, most of you. The rest of you are liars. Because we have all, at one point, who has ever written a utility class? Right, right. I will tell you, more hands were raised for that question than the previous question. Right, so the idea is just because you can put everything in one class, don't do that. So, single responsibility principle, whoever said it, and you said it very succinctly and very nicely. I'm going to use a lot more words for just a second. Every module or class should be responsible over a single thing. And it should be entirely encapsulated within that class. And I'm using the word class, even though JavaScript does not have classes. I don't care that they have a class keyword. JavaScript does not have classes, but all the services should be narrowly aligned. So a class should have one reason to change. So why? So forget all of the implementation details of single responsibility. Why should an object or a thing have only one reason to change? Because what happens when you change something? You break it. And so the more often I'm in something, changing something that works, the more often I am likely to break the thing that already works. Okay, so React developers, there were a few React developers in the room. I'm going to throw some code up here. And I want you to tell me if you've ever done this, because you have. Okay, this is a simple React component that does a few things, which already we can see where I'm going. Okay, so when it loads, so in my constructor, I do an axios.get. So basically I do a fetch. I go on and I pull the data right here in my component. Red like flags should be going out all over the place. Okay, and then after I've gotten my data, I come down here, I loop over my data. So what happens when my API changes? I have to go crack open all of my components and change my API. What happens when the way I want to sort this, where I've got to crack this open and I've got to change the way I sort it? So I'm doing many, many things in here, and I don't really have to. And that's the thing with JavaScript. And what you'll see is the answer to a lot of these things in JavaScript, and single responsibility is like the easiest of all of them. So it like takes 2 minutes to talk about. In JavaScript, so in the framework, so if you're Angular or you're React or you're whatever, there is no reason to build everything here other than laziness. And actually, it's even more work to do that because I can handle all of this stuff up above and I just pass it all down. So if you ever find yourself in a component and you're writing API code, you need to think to yourself, why am I doing that? Stop it. Pull it out, and just pass the stuff down on props. And now I'm looping over props instead of building things in a state and making things more complicated than they need to be. That's it. So I'm not going to talk a lot about single responsibility because all the hard stuff comes after that. But think in your head, it's going to do one thing because I don't want it to change. Okay, open closed. This is where it becomes a little more interesting. So, okay, so who said, I had like 4 people who said open closed. Open closed principle. Say that one more time. Right. It's almost as if you've seen this before, right? Yes. Right. Software entities should be open for extension, closed for modification. Why? Again, same thing. You have something that works. And now you need to add some functionality. If you go and you start putting if statements in your code to say, well, I want it to stay this way, but then in some cases I want it to do something else. You start to break things, and you'll see a theme. A lot of the solid principles come down to don't break stuff, which leads to this. How many of you have ever inherited things in JavaScript? A few. A very few. Right. So I have I'll walk through an example of some inheritance options in JavaScript to kind of talk about. So first things first, I have an object. It is an object, it is not a class, especially since I'm not using class. So I have a constructor function. And this function, capital T, what does the capital T in task mean? It means when I use it, I'm going to do a new, right? So that's a standard thing to keep. So I have a task that has two things on it. It's got a name and whether or not this task is completed. That's it. It's simple because it makes a good example. On tasks prototype, who can tell me what a prototype is? Okay, a few. So a prototype is a collection of things that all of the instances of the object share. They don't make copies of the prototype. They all point back to the prototype. So if you change the prototype, you change everything. So don't do that. Okay, so I've got two things on the prototype. I've got complete and I've got save. So basically I'm going to complete something and I save it. That's all there is to it. And I have an implementation. That box is very tall. So you little group right here, it says var task equals, and then we knew something up. Everybody else already knows that. Okay, so, sorry. Right, and then we complete and we save it. Okay, so we have built an object. We've built a task manager. I have task everywhere throughout my code. And what happens? My boss comes to me and says, we need you to change something right now. It's urgent. And the thing that is, how many of you have gotten like requirements changes? All right, I mean, that's like an easy, we all have, right? And so in this case, they want the ability to create what is an urgent task, which has a priority associated with it. And when things happen to the task, people get notified that it happens. So how do you deal with that, right? You come back here, and right here you put an if statement that says if it's urgent, then you send notifications. And you come down to save, and if priority equals right, and now we're breaking things. So open close principle says don't do that, right? Things are you're open to extension. We do not modify this. But I have good news for you. We're in JavaScript where no rules apply. This becomes very easy. Don't worry, I won't stop here. Like, don't become angry. I'm going to start with this, and then So I have a new task. I just knew up a task called urgent task. And because this is JavaScript, and I just start adding things to it. So I can do urgent task.priority, urgent task.notify, which gives me a new function. I've got a priority now, and then I overwrite save. Save for this one thing now means something different, but I can just do call on task.prototype now, right? This is ugly, right? You don't like this at all. No, you're smart. I agree with this. Don't do this. But I have to start here, so then we can expand. Okay, you can do this, but unless you're that guy, then don't do it. And then I can just do urgent task.complete, urgent task.save, everything works. Okay, don't do that. There's a better way. Believe it or not, I actually can inherit from task and create a new thing called urgent task. I can just create a new constructor function, and when that constructor is called, I call tasks constructor, and then I just add priority to it. I copy the prototype. I actually copy the prototype. Don't reference the prototype because we're going to change some things, but copy the prototype, and then start changing stuff. So I add notify to the prototype, I add save to the prototype, which calls notify. And then notice I'm calling back to task.prototype.save, because if that ever changes, I want to still be referencing it. So what this gets me there we go, is now I can just do this. So everywhere I had task still works. Now I have this new thing called urgent task works. It's all just good. Right. And it's that easy. But it's not quite that easy. Because then we get into stuff like this one. Okay. Oh, what happened? Oh, no! I pushed a button that I didn't even know I had a button that did that. It's like I've never done this before. Okay. So, who knows who Liskov is? It is, yes, and you're inferring that probably from the fact that I have she here. Okay, so this is the funny thing about the Liskov substitution principle, because most of you have heard the phrase Liskov substitution principle, but you have probably never heard of the person Barbara Liskov. And I find that a little unfortunate, so I'm going to just take 2 seconds, more than 2 seconds, but not a long time. So Barbara Liskov is a professor at MIT. She wrote languages. She wrote the first object-oriented language. She wrote the first object-oriented database, and she called it Thor, which is kind of awesome in and of itself. She's got Turing Awards. She's got all kinds of stuff. Most of what you do every day in C# and object-oriented programming originated from the work that Barbara did back before we all got started. So she's awesome. And unfortunately now all we know about her is she has this weird solid principle that nobody understands and nobody really knows what it is. So I wanted to rectify that for just a second. Okay. Liskov's substitution principle says this. I'm just going to read it. Let Q of X be a property provable about objects of X of type T. Then Q of Y should be provable for objects Y of type S, where S is a subtype of T. There you go. Right? Which is usually where people stop, right? They're like, I don't care about this one. Let's move on. But we're gonna do this. Okay, so here's the summary, right? So if it looks like a duck, quacks like a duck, but needs batteries, it's not the right thing. So the example that is used to talk about the Liskov substitution principle usually involves a rectangle. So I'm going to walk through this example for you with the formula, and we're going to see if this makes any sense whatsoever. How do you define a rectangle? This is not a trick question, so feel very comfortable. How do you define a rectangle? You have how many sides? 2. You have 4 sides, but 2 different sizes of size, right? So you've got length and width. What else? Because a parallelogram has 4 sides. 4 right angles. Excellent. So 4 sides of 2 different lengths with right angles. That is a rectangle. Everybody agree with that? If I change the bottom length, the top length changes too. Okay. Is a square a rectangle? Yes. How do you define a square? Wait, did somebody say the same? Don't answer, because you're not right. You are right, but also wrong. How do you define a square?
Same side, 4
right. So technically, if I have an object that is rectangle, I could substitute a square in there most of the time, right? Because a square has a length and a width, but they have to be the same, and 4 right angles. So if you were going to set it up, would you inherit square from rectangle, or would you inherit rectangle from square? You would inherit square from rectangle, which is the default answer that most people give. Somebody over here was violently opposed, which makes sense, and we'll get there. Okay, so we already did that. Okay, so back to this. Let Q of X be a property of, okay, let's say I have Q of rectangle, right? So we're here. Let Q of X, where X is a type of T, I'm just going to simplify this and say Q of rectangle. I pass rectangle into a function, and that function does stuff with it. If I pass square into the same function, will it work? Yes. If square extends rectangle, then it should work. Okay. So we're saying that Q of X is Q of rectangle, and that's a property proven about objects of type T, of type rectangle. Then the same function where a square is going to be exactly the same thing. Okay, excellent. So let me give you a theoretical question then. If I pass in square, and what the function does is change the width of the square, and then validates that the length has not changed, will it work? It will not. Because the square adds a restriction that will also change the length when you change the width, because it has to in order to be a square. Therefore, it's not the same. It does not operate the same way. And realistically, it's a silly example at all, because squares and rectangles aren't really all that alike, actually, anyway. A square only needs one variable to define it. A rectangle needs 2, so why would you make it more difficult? Okay. Let's go back to this. I have a task, and I have a function that we pass a task into that calls myTask.complete and myTask.save. So, and that's the task that processes tasks. Let's just say, or that's the function that processes tasks. If all of a sudden I start passing in urgent task, remember, because I couldn't just change task, I had to create urgent task that extended task. Can I pass an urgent task into that same function and have it still work? That's what Liskov is trying to do, because when you get to the point where you're extending everything, you don't have to want to rewrite all the stuff that uses those things. You want to be able to pass the subtypes in and have your project still work. That's the whole point. So in this situation, my task equals new task, and then I complete and I save. If I pass urgent task in, does it still work? How do you interact with urgent task? You still have complete and save, right? It's the same. So my task, complete and save, that's what it says, I promise. And urgent task was complete and saved. The API to interact with the object is the same. It still works. So Liskov is valid for that, if that makes sense. So that's what she's trying to prevent us from, the problem she's trying to prevent us from getting into is make sure your stuff works. Really, that's what it comes down to. Like, don't make things more complicated. Keep them simple, and so that when you start extending things, they all just work. All right, now you can ask your question. Interface segregation. We don't have interfaces. So here in this one, it's a little more like loosey-goosey. That's probably not a phrase you guys have in Bulgaria, is it? Loosey-goosey? No? It means, I I don't even know. I couldn't even tell you what it means in English. Not very constrained, right? So, okay. So what I'm going to do, because we don't have interfaces, what I'm going to do is I'm going to go all the way back, and I'm going to talk about why interface segregation was even talked about at all. And then we're going to take that, and then we're going to talk about it in the context of JavaScript. So, right. That is a very complicated interface. I just want to plug something in, and I don't know where to plug it in. I don't know what to do. I don't know how to use it. That's a problem. So, here's the deal. So, here's the definition. So, no client should be forced to depend on methods it does not use. So we split very large things into small things so that we can use them a little bit easier. Ultimately, it comes down to that. Keep your interfaces simple. And when I say interface, I do not mean interface, like a C# interface. What I mean is the thing you use to interact with something. So if I have, well, I'll get there. Okay, so Bob Martin. How many of you have heard of Bob Martin? Uncle Bob. Okay. So Bob Martin used to work at a company called Xerox. This is, I will tell you, before the days of C#. C# did not exist yet as a language, and they were doing some consulting from Xerox. Okay, I'm gonna read this a little bit, and what I want you to think about is how many of you have ever, I'm also not gonna lean on that, have ever interacted with code like this. Okay, here we go. Xerox had created a new printer system that could perform a variety of tasks. We could do all kinds of stuff with our printers. We could staple, we could collate, we can like fax, we can do double-sided things, like we had all kinds of stuff. They created a blob. We have one set of code that does everything, which is a violation of the single responsibility principle. So we could have avoided this whole mess if we just would have, but this was before the solid principles. So how many of you have ever dealt with blob code? All of you have, right? At some point, one time or another, you've all had blob code. And this is a cute blob, like it's fine. It's okay. As the software grew, making modifications became more and more difficult. So that even the smallest change would take a redeployment cycle of an hour. This was making it nearly impossible to get anything done. Blob. Not cute blob. Very hard to deal with blob. And so we have code, and how many of you own end-to-end the entire code base that you are working with? Okay, I have a lucky few. You are probably not immune to this because there's no worse developer than you 6 months ago. Like, that's just right. We hate our future selves, always. Okay, so we had this big blob of code, and you can't always go in and change things. Sometimes you just have to deal with what you get. You can't go to your coworker and say, you violated single responsibility, I need you to change that. Sometimes you just have to deal with the code that you're handed, and that's what Bob Martin had in this situation. Okay, because of this design, a stable job had to know about print job and all these other things that were going on. So out of this conversation, because we had all of these things going on in this one thing, he came up with this concept of the interface segregation principle. So that is the context that we're going to talk about interface segregation. There's a lot of other contexts we could use. I'm going to use this one because it works for the point I'm trying to make. Okay. So basically what they did is they layered a series of interfaces on top of this job code. And so really all they had to know about was like, hey, this is the staple stuff. And the staple thing only needs to know about the staple stuff. And the print stuff and the collate, and they start to chunk it out. And they didn't change the job code at all. They just used interfaces to deal with it. Now, as we know, we don't have interfaces, so what are we going to do? So instead of having one large job class, it just had interfaces. We don't have interfaces, and so that becomes a problem. We have a slightly different way that we can come up with the same basic idea, because we're going to come across blob code, always. And so there is a pattern in the design pattern library that is similar but not the same. So don't throw, so it's similar, and it kind of gets us there, which is the facade pattern. How many of you know the facade pattern? Okay, all of you, almost. You guys are going to stop raising your hands if I do. What is the facade pattern? Somebody tell me. What? Oh, it's already there. Okay, so yeah, it's an object that provides a simplified interface to a larger body. So the facade is like the front of the house, right? So you've got a building, and the front of it hides all of the grossness back behind. And in many cases, that's exactly what's back there. So we want to provide a clean, simple interface to something that is not clean and simple. And that actually is not a difficult thing to do, especially in JavaScript. So here we have a job service. And this job service is gross, because when I create a new job service, I have to know what the job type is. So if I'm a printer, if I want to print something, I create a new job service printer every time. And then I have to call, because staple doesn't want to do everything all at once, but print wants to do complete, set the complete date, notify, and save. Staple doesn't want to do any of that stuff, so you have to call everything individually to deal with it, and that's stupid, and we don't want to do that. So what we can do instead is so I've got a job, that doesn't matter. So I actually can create a facade that sits on top of my job service. And say, hey, I have a print job. Oh no, that's how I use it. Here we go. I have a printer service that creates a new job service that already does print. It creates a new function called complete that calls all of the stuff for me, so I don't have to call it. And then I can use the printer service everywhere. I now have created a very simplified interface that sits on top of my job service, and every time somebody changes the job service, I just go into my facade, change it up a little bit to match, and then everywhere that uses it uses this thing. It's not hard. It's not even complicated. It's just something that at some point you have to stop for a second and say, I need to do something a little simpler than this. What's a simple way to do it? And then you come up with something like this. And that makes it so much easier. I have a lot more code that I'm not going to reference at all. Okay, that's the idea of dependency inversion and kind of how we attack that on the JavaScript side. Or not, interface segregation. Questions on that? You don't have to have any. Okay. Dependency inversion, this is my favorite one, because it's the simplest one. It's the simplest one. Okay, so how many of you have a lamp in your house? Many of you, okay. I don't know if that's a trick question or not. Okay, so when you plug a lamp into the wall, you don't require a soldering iron, right? If you move a lamp from one place to the other, you just unplug it, move it over here, and plug it back in again. It gets slightly even better than that. So check this out. I have a MacBook, and it has this little thing. That is kind of cool because it's just magnetic, and you can stick it in. Oh, okay. But here's the thing with this. The MacBook has no idea what's coming in. As long as it fits in the hole, it works. Right? As long as it's sending the right stuff. If it's sending, don't. Here's the interesting part of this. I bought this laptop in Missouri, Kansas City, Missouri, in the middle of the United States. My plug does not look like this. Not at all like this. Well, it has two things, but they're flat, and they look very different than this. But my MacBook that I bought in Missouri still works here. You just saw me unplug it, right? Because I have this little thing that goes from being 2 flat prongs to 2 round prongs, right? Everything to this point doesn't care. It has no idea what's on the end of this. All it knows is that it needs the right type of power coming through the end, and it just relies on that. And if it doesn't get it, it blows up. In fact, like, not figuratively blow up, but like actually blow up. So you got to be a little careful. But this ultimately is what we're going to talk about with dependency inversion, right? This thing does not care what's coming through here. It relies on it. It has to know what it is, but it doesn't care how it gets there. And that's actually incredibly simple to implement, especially in JavaScript. I've only got 5 minutes. It doesn't matter. Okay. It came out when I dropped it because that's what happens. Okay. So this is for you. Here you go. High-level modules should not depend on low-level modules. Both should depend on abstractions. Abstractions should not depend on details. Details should... Do we have these things in JavaScript? We do not. So no. Don't worry about all the fancy wording. Come back to the example of the plug, right? At its core, when I have code, back to the single responsibility. So this ties all the way back to what we talked about in single responsibility, right? I don't want to do everything here. I want other things to provide me with what I need, and I don't care where they come from. It is okay for your code not to know where other things come from. It doesn't matter. At some point, you just have to trust that that's going to be the right thing. Because if it's not the right thing, it's going to blow up, and that's what we have QA for, right? So, do I have any QA in the room? Like, QA are my favorite people in the whole world. Because the reality is, I tried to have this argument once with a QA person. When you write code, and that code goes to production, and it breaks, who gets yelled at? You know that's not true. Okay, right? You do. When my code goes to production and things break, nobody goes to QA. They come to me and they say, why did your stuff break? And so what we've done is we've hired people whose whole job is to prevent me from getting yelled at. Because they're going to find the broken stuff so I bring them donuts, like whatever you guys need. I am here to help you because your job is to make sure I don't get yelled at. Okay. So this is simple. I'm going to make this is almost as simple as single responsibility, except I don't even have to change anything. I've got this code that, I've got this thing right here. I have no idea what that does. Not a clue. And I don't care. All I know is that when you click on a button, I'm going to call a function. And as long as that function is there, my code works. This is ultimately the core of what single responsibility is. Because if we want to change what save does, whoever defines that, you do that over in one place, somewhere else. And then I just pass all that code down. It's kind of like back at the beginning, we were passing things down on props. We were passing our item list. It's not really the same thing, but I'm just going to send stuff, and I don't need to worry about interfaces or abstract classes or any of that stuff, because who cares, right? It will make my life easier later. But we're in JavaScript. I don't have it, so we make do with what we have. Okay, so that's like a whirlwind tour, because we only have so long to kind of like through the concepts. And remember what I said at the beginning. The beginning was, I'm going to give you some things to think about so that when you're sitting down writing your code, you can think, wait a second. this is not the right thing I should be doing. Let me see what I can do to make this a little bit easier. Just give yourself the excuse to take a step back for a second and do something with it. Because the reality is, how many of you have had this conversation? How many of you have inherited code that's terrible? How many of you have inherited code from yourself that is terrible? Right? We all have. What we're trying to accomplish when we start stopping and thinking about things a little bit better is somebody else, usually you, has to use this code later. Save yourself some time and make things better first so that 6 months from now when you have to go back and change something, it's a little bit easier to do. All right. That is my talk. So thank you guys very much. I'll be up here for just a little bit if you have any questions. Otherwise, you're done for the day. You can go home, you can go to dinner, you can do whatever you want, and then you have to come back tomorrow. But that is what it is. So thank you guys very much.